It's a great pleasure to have today for our seminar Gene Grossman from Princeton University. Gene doesn't really need a presentation because he is one of the leading experts in many fields, in particular international trade theory, which has given a lot of seminal contribution. He has done also a lot of work on endogenous growth, on political economy, on strategic trade policy and trade policy in general. And the paper today is written with Ellen Altman and Philip Kircher on matching and sorting in the global economy. Thank you.
Thank you. It's a pleasure to be here. Thank you for the invitation. So this is a paper that's not about data and empirics. It's going to be a theoretical paper, but it's motivated by a lot of interesting data work that's been done recently. Made possible in large part by the construction of matched employer-employee data sets that allow us to learn the history of workers' experience in the labor market, their wage outcomes in particular, employment outcomes, and allows us to track them to across particular firms that they work for, and to match the workers with the characteristics of the firms. So just to list a few of the kinds of facts that I'm thinking about. There is work showing that, so trade theory typically talks about aggregate factor endowments. Countries are abundant in human capital or in natural resources, unskilled labor like China. But there's recent work showing the distribution of factors, that is to say the concentration and diversity of the population in terms of their skills not only is it a source of comparative advantage, as the first bullet point says, but it's in fact as important as the level of factor endowments in determining trade patterns. In other words, countries with very diverse populations, lots of heterogeneity of skills, tend to export certain goods relative to other countries where there's a more homogeneous population. We know that much of trade theory is concerned with income distribution, the effects of trade on globalization, on income distribution. We tend to focus on cross-industry or cross-factor income distribution, capital versus labor, or workers and import competing industries versus workers and export industries. What we've learned recently that much of wage inequality, and indeed much of the effects of globalization on wage inequality, comes within firms and certainly within industries, and oftentimes even within firms. We've learned from the work of Otter and Larry Katz and others that the recent effects of technology and of globalization on income distribution are more subtle than the skill-unskilled skill premium that we've tended to focus on in the past, and in particular, at least in the United States, and I think also to some extent in Europe, there seems to be a polarization of the wage distribution recently, with, of course, increases at the top end, but also increases at the bottom end relative to the middle. We've learned that export firms pay higher wages than other firms. Firms that export pay higher wages than other firms, even to similar workers with similar characteristics, or seemingly similar characteristics. We've learned, perhaps, the evidence is still a bit unclear, but perhaps that there's positive assortative matching between firms and workers. Firms with more sophisticated technologies tend to hire the better workers even within similar skill groups, something you'll see in today's model. And in particular interest to me that the degree of trade openness or trade policy affects the matching of workers to firms within industries. So none of this data am I going to particularly talk about today, but it's in the back of my mind as I think theoretically about the role of heterogeneous workers in trade. So this is the literature that I'm more coming out of. It's a theoretical literature that tries to think about how heterogeneous labor affects trade patterns and the effects of trade on income distribution. What we find in the literature is several papers that look at what I'm going to call sorting. Maybe I just define the word. I'm going to use the words, you see the word sorting and matching in the title of the paper. Those words often in the literature are either used interchangeably or used in a confused way. I'm going to use them very particularly just to have a terminology. And I'm going to use sorting to talk about which type of workers sort to which types of industries. And I'm going to use matching to ask which types of workers match together with which types of technologies within industries, or with which types of workers within industries. So the literature on sorting tends to assume linear output. That is to say, each worker's output is in different industries. Perhaps he has different potential output in different industries. Perhaps he has comparative advantage in certain activities. Be that as it may, since things are linear in those models, each worker can make his own decision about where to sort to without having to worry about anybody else. And there are no equilibrium interactions there. Each worker's productivity depends only on his own abilities and not on anybody else with linear output. So that's a very restrictive set of circumstances. Even more restrictive are the papers in the literature that study matching. Typically they do so in one-sector models. So when there's matching, there's no sorting. When there's sorting, there's usually no matching. So what this paper is about is really to think about the interaction between the two. So I'm going to think about workers that are heterogeneous in their types and their skills, in equilibrium deciding which sector to sort to, in equilibrium deciding which types of firms to match with, or which type of managers in the model I'm going to talk about to match with. And I'm going to do so in a world where there are non-linear effects, so that each worker has to take into account in equilibrium how the other workers are making their choices and making an optimal choice of their own. So as I said, this is going to be, from here on in, an unabashedly theoretical paper. I'm not going to further talk about the data. In particular, we're not trying to explain any of these particular facts or observations here. Whoops. Rather, what I want to do is show you a very plain, familiar to you if you studied any trade at all, very familiar trade model in which the only way we're going to change things is to introduce labor heterogeneity into the setting. And I would argue that the forces that I'm going to study here are going to be present, have to be present in any model that one constructs to look at the data, because they're really the basic forces at work. As I said, I'm going to introduce linear returns or diminishing returns to the quantity of labor, and so that the choices of different workers will be interactive in that sense. And I'm going to introduce complementarities between factors that generate positive assortative matching. Okay, to be more specific, again, for those who are familiar with trade, you know that the acanonical model, sometimes called the old trade theory now, in deference to the work starting with Krugman. Acanonical model is the Heckscher-Ohlin model. It's the model with two industries and two factors of production and perfect competition, and that's exactly what I'm going to work with today. The only distinction, and it's an only that took us 1.5 years to write this paper because it's not so trivial, but the only distinction we're going to make is we're going to assume that each of the factors is heterogeneous, that labor comes in different types, and that the second factor, which I'm going to call managers, also comes eventually in different types, although I'll start off by assuming that the managers are homogeneous. So I'm going to study a Heckscher-Ohlin model with factor heterogeneity to make things very transparent. For the most
as well?
I'm sorry?
To country as well?
I'm going to study a supply equilibrium, 2 countries, yes, basically 2 countries. Sometimes only 1 country, looking at the equilibrium given the prices, and sometimes 2 countries. Okay, at the end, if there's time, and in my previous presentations of this paper there never has been time, but there could always be a first. We also show how the model can be extended. So all of this is going to be perfect competition and frictionless labor markets. Of course, we know that labor markets are rarely frictionless. We look around us and we see the frictions every day. And so we also show at the end of the paper how the model can be extended to allow for a particular type of friction, namely labor market search that Diamond, Mortensen, and Pissarides and others have made famous. Okay, so here's a list of the types of questions we're going to address in this setting. What determines the sorting of workers and managers to the sectors? What determines the matching of workers and managers within sectors? And just to be clear so that there's no confusion, although workers and managers, I'm going to call the factors workers and managers, these are 2 separate factor supplies. There's no occupational choice here. A worker can't choose to become a manager. A manager doesn't want to choose to become a worker, let's say. There are going to be exogenous supplies on each side, but there are going to be heterogeneities of both of these types of factors. What determines the pattern of trade between 2 countries that have different distributions of workers and managers, say? How does trade affect the income distribution? That's a classic question of trade theory, but notice now with this heterogeneity, I can speak to more than the relative wage of the workers versus the managers. I can speak of the whole profile of wages from the best to the worst worker and from the best to the worst manager. So I can ask how trade affects that entire wage and salary distribution. I'm going to talk a little bit about how trade affects productivity in this model. And I'm going to talk about, or not talk about as the case may be, how trade affects employment and unemployment rates once we introduce labor market frictions. And I'm going to expect you to interrupt me as we go along with questions, otherwise we'll all get bored. Okay, without further ado, let's jump in. Yes, 2 countries. Different in their factor endowments. The factor supplies are exogenous, just like in a Heckscher-Ohlin world. The 2 factors, labor and managers, or workers and managers, as I said. L bar C is the stock, or the measure of workers in country C. And phi LC is a probability distribution function. So L bar C times phi LC is the measure of workers that have this particular ability or talent or quality level, QL. Okay, so if this distribution were degenerate, we'd be exactly in the Heckscher-Ohlin world. It's the heterogeneity coming from the exogenous supplies of different workers of different types. That's the new feature here. Similarly, on the manager side, to introduce some ideas, I'm going to start off just assuming the managers are homogeneous, but where I want to get to is assuming symmetrically that there's a distribution of managerial talent as well within the country. So 2 countries trade because they have different distributions of labor and different distributions of managers. Okay, otherwise, like in Heckscher-Ohlin world, they have the same technologies, similar tastes, all trade, all comparative advantage is going to come from these different factor supplies.
So you have a continuum types.
We have a continuum of types. Yes.
These are completely exogenous.
Completely exogenous. Yes. Although
Labor is not allowed to move between countries.
labor can't move between countries, and labor can't move to become managers. And labor can educate themselves and make themselves better quality labor. All of that, of course, is interesting, and one would want to do that as future steps. Okay, 2 industries. In industry I, which I will imaginatively call 1 and 2. In industry I, managers look at the production and define a production in terms of, so there's going to be overall constant returns to scale. So I can define the in terms of what one manager of type QH can produce. So one manager of type QH combined with L workers of type QL produces what you see here. So let me describe it. So this is the productivity of that team, of the manager and this group of workers. This is the productivity term in industry, indexed by I. So the quality of the manager will affect the productivity of the unit. The quality of the workers will affect the productivity of the unit. And, of course, because it's a function here, there can be interactions between the two. The quality of the manager can affect the productivity of the workers. In general, it will, and vice versa. Okay, so that's the productivity. And then this is the number of workers raised to the power gamma I. Okay, so here's the diminishing returns to the quantity of labor given the productivity of the unit. Differs across the two sectors, reflecting the fact that these two industries have different factor intensities, as in the standard Heckscher-Lane model.
So all the workers that match with a single manager are of the same type?
Doesn't have to be, as one of these bullet points here. Primitive technology could give output as a function of a list of type of workers. When you write that down, a given manager will want to hire a particular type of worker, and we just save some notation by already writing the technology this way. Okay, I'm going to assume that, so far this is only a descriptor or an index of the type of the workers and managers. By assuming that having a higher index makes you more productive, I'm going to associate the index with quality. Okay, it doesn't have to be the same for both sectors. Having more IQ is good whether you're a basketball player or a professor. Presumably it helps more in being a professor than being a basketball player, but it helps no matter where you are. Okay, as I said, overall constant returns to scale. So if you have H managers of type QH producing with this technology, their total output will be H times the productivity times the number of workers per manager, which is L over H. So overall constant returns to scale. Because of overall constant returns to scale, I can work with a competitive model, and that's what I'll do.
Sorry, could you, again, on the previous point, about this different type of workers that can be hired by the same firm, but you're saying there is no reason for firm to do that? Why that? What is
so the micro foundations would be the manager has a unit of time, and he can allocate his time managing, if you will, the different workers, which makes them more productive with diminishing returns. So if I have two workers, say I might want to split my time between them, or if they're different quality, I might want to spend more on the good worker than the bad worker. If you work out that optimization problem, a given type of manager will typically want to hire one type of worker, and therefore just to save on notation, I'm just going to assume already that that's what happens, what comes out. There's no reason here in the technology that makes it advantageous to have a lot of different types of workers. Whatever type is best for a given manager. And also because it's a continuum, you can always find however many you need of the type of workers you want to hire.
This implies positive sorting or not necessarily?
This is with positive sorting. It doesn't apply it. It's the same technology assumptions that generate positive sorting will generate this conclusion. Okay, so as I said, let me start with the simpler case. Let me start with the case where the set of managerial types is degenerate, where all managers have the same type, and without further loss of generality, I'll just set that type equal to 1. I'll just pull out 1. And just to save on some notation. I'll put a tilde over variable for the productivity of a manager with ability 1 and hiring workers of type QL. This thing that you see here, I'll just call that, I'll suppress the 1 and put a tilde over productivity. Okay, so what are the profits of this firm? Well, clearly enough, if the competitive price is PI in industry I, here's the productivity, here's the diminishing return, so here's the output, and the total thing is revenue. If I'm hiring workers of type QL, I'll pay a wage, W of QL. Remember now, since workers are heterogeneous, and since we have a competitive market here, there's an entire wage schedule. I can choose what type of workers I have, but presumably in equilibrium, the better workers will be paid more, which is part of my decision here. It's the essence of my decision here, in fact. But I also have to choose how many of them to hire, and I have to pay my manager. All the managers are the same for the time being, so R is their salary. Okay, so this is standard profit maximizing problem. The new feature is we're choosing not only the quantity of labor, but also the type of labor. Okay, it involves an obvious trade-off. Hiring better workers is good news. They're more productive, according to this, but it's bad news because they're more expensive. And you have to, each firm has to decide which type to hire as well as how many to hire. Yes. Okay, well, let's do it in 2 steps. Let's take the type as given for the moment, or consider conditional on hiring workers of type QL. How many of them do you want? Well, now it's an absolutely standard problem, and we just get the labor demand related to the wage according to the diminishing returns, as you see here. So just write the first order condition with respect to the number of workers, and you get this relationship. Think of it as a labor demand schedule in quantities. Substitute it back in, and now we get a profit function that depends upon the quality or the type of the workers that you choose to hire, already realizing that you will hire the optimal quantity once you choose your quality. So that's what you see here. And now the firm has to optimize this guy over the choice of QL, and as I said, here's the good news, and here's the bad news. Okay, so the first order condition can be written this way. Let me explain the terms. So this is the elasticity of the productivity schedule with respect to ability. So as we hire more able workers, they contribute to productivity. How much so? Well, that's captured by this elasticity here. Need not be a constant. For some functional forms that I'll show you, it will be a constant, but I'm not going to all the way through assume it's a constant. So I write it this way, the elasticity that depends on the quality. This here is the elasticity of output with respect to the quantity of labor. You can see that up here. Okay, could have been more general, but I've chosen a Cobb Douglas for this functional form, so I've made that elasticity a constant. So this is the ratio of 2 elasticities. How does output respond to quality? How does output respond to quantity? And it's a horse race between the two, and you can see what the first order condition tells us is to set that ratio equal to the elasticity of the wage scale, equal to how quickly wages rise with respect to quality, measured as an elasticity. There's 2 ways, one more sentence and then I'll, two ways to expand your output this way in this firm. You can hire more workers, or you can hire better workers. It's said that high-tech firms like to hire few workers but better workers. Walmart likes to hire lots of workers. That's telling you something about differences in their technology. And so this choice is playing off that trade-off. It's going to cost you more. If you want to hire better workers, you're going to hire more. They're going to be more productive. The temptation to hire more of them is going to get expensive, and so you can either hire more, if this is big, you want to hire more workers, and if this is big, you want to hire better workers.
It reminds me of the model by Limer in which it's actually workers choosing the effort on the basis of a wage scale that is then competitively.
It has some family resemblance, yes. There wasn't a question, so I want to answer it.
No, I was wondering what is the relationship. Okay, the distribution of abilities, exogenous.
So this, if we ignore these bullet points for a second, this would seem to tell you, for firms in Industry I, their optimal choice of what type of worker to hire. Okay, we just find the QL for which this first order condition is satisfied, and that would say what type of worker you want to hire if you're working in Sector I. But there are two sectors, 1 and 2. Okay, so if that were the end of the story, there would be some optimal type for hire for Sector 1, and some optimal type that hires Sector 2. All the firms in Sector 1 would hire their optimal type, all the firms in Sector 2 would hire their optimal type, and everybody else would be unemployed. Okay, that doesn't sound like a competitive equilibrium, because if everybody else is unemployed, their wage is 0, maybe it would be tempting to hire somebody at a wage of 0, rather than the guy that you were intending to hire. And to make a long story short, rather than determining the type that each firm chooses to hire here, rather what this condition pins down is what the wage schedule has to look like. Okay, the wage schedule has to be such that in equilibrium firms are indifferent over a continuum of types, so that all of those continuum of types get higher. Since all the firms for the time being are the same, they have a manager of type 1, they have the same technology, all the firms within the same industry are the same, they have to be indifferent if everyone's going to get hired, which tells us that the wage schedule has to have exactly this elasticity if everyone is going to be hired. Yes, question?
I'm just a little bit lost. I do not see managers-workers relationship, because you said there are continuum types of workers, and then you mix with the managers, you match with the managers. Now we have a single homogeneous manager,
Yes.
but you still have a continuum types of workers, right?
Yes.
I do not, well, if you match with the different types of workers, the productivity that industry it must be different. If the managers match with the other types of, let's say there are two types of workers, A and B. If the homogeneous managers mix with the A type of workers, there's a productivity of some level. And then otherwise, if the productivity will be different if the managers match with the B type of workers.
That's correct. And the wages will be such that there will be an equilibrium indifference between those two, otherwise we can't have an equilibrium.
But the thing is, I do not see from this slide where I can inference that if the managers match with the different types of workers,
Well, it's here. This is the manager. This is the productivity of the unit, depends upon the type of workers that he matches.
okay, then I follow you.
Okay, and it's the elasticity of that relationship which influences the wage schedule.
Okay, then I follow.
Okay, so within each sector then, so all the workers who sort to Industry 1, say it's going to be some group of workers, within those workers, the wage schedule has to have exactly this elasticity.
Sorry, what does it happen if there are constant return to scale then?
There are constant returns to scale to the workers and managers together.
Yes, but only on worker side, gamma is equal 1, yes.
So then you get that.
Yes.
That's fine. Then the manager becomes irrelevant to
Yeah,
production.
yeah,
He gets
okay.
a return of 0. and then we're back in the world of
Yeah,
Kostanev's
okay.
econometric. Okay, so the wage schedule now has to have, for all the workers who sort to industry I, which I'll write this way, so this is the set of workers who sort to industry I. For all types in that set, we have to have the wage schedule having the elasticity that I indicated here, namely this one. We can solve that differential equation, and the wage schedule is going to have what we call a wage anchor, and then it's going to rise with productivity with the right elasticity. Okay, and that's going to be true in each sector. Okay, so all I've done here is solve the differential equation once I've realized that this is the elasticity the wage schedule has to have for all the workers in the same industry. Okay, and I'm going to define this thing here, which is the difference between these two ratios. So remember, this is the elasticity of productivity with respect to quality divided by the elasticity of productivity with respect to quantity. This is that ratio for industry 1, and this is that ratio for industry 2. And I'm going to call the difference SL. Okay, well, there are several possibilities here. At different levels of QL, one of these guys might be always bigger than the other guy. Or the alternative is that they might switch places depending upon what level of Q we're talking about. So let me talk about first the case where they don't switch places. Okay, so the case where industry 1 always has a higher elasticity than industry 2. Okay, well then I can plot these wage functions, and you see them here. There's the one with the low elasticity and the one with the higher ratio of elasticities. You can see because this is always steeper than this at any given point. They can only cross once. And so the wage schedule for the economy is in fact going to be this patched together with that. In other words, all the best workers are going to go to sector 1, and all the worst workers are going to go to sector 2 with some endogenous split point. So that already is my answer to the sorting question. In this model with homogeneous managers, look at the ratio of these two elasticities. The best workers go to the one where the ratio is higher, where quality is more important and quality is less important. So that's the high-tech sector in the example I gave before. Here's the here's Walmart, where quality is less important relative to quantity. Okay, the best workers are going to work in the high-tech sector. The lower-tier workers are going to work at retail. That's the way. Okay, so let me, if everyone's with me, let me push forward now.
Should we just make up my mind, even because I have some difficulties to see from here. So basically what you have is a set of first order conditions and then dimensional set, right?
Yeah.
Depending upon L.
Yes.
Because L can go, I don't know, from 1 to capital L. So you have capital L.
We have a continuum, in fact, of worker types.
Exactly. Therefore, what you are saying now, I mean, the first question I would like to ask is how to select a particular L. How can a firm select a particular?
Well, there's a competitive labor market out there. Everybody has on their forehead their quality branded, so everybody knows the quality of all the different workers. There's a wage schedule, and each firm decides they want to hire a worker of quality 23. They have to pay the wage, $40 an hour, and I'm not sure what you mean by the question, but that's how they do it.
No, I mean,
Yeah.
I wanted to know whether there was a rule, because apparently there is no rule. Okay, they can pick that particular L by paying
Yes.
more or
Competitive.
less, or another L by paying more or less.
It's perfect competition with many different labor markets that are not independent because you can always choose to do something different.
Exactly. And therefore, by looking at that picture, you are talking about country 1 and country 2.
No, industry 1 and industry 2.
Industry 1 and industry 2.
So the industry
Well,
1,
can be also the reverse of.
Well, if this were reversed,
Yeah,
then this would be reversed.
yeah, okay.
So this is the condition that determines.
No, just to have the overall idea about the model. Thank you.
Okay, so I'm going to continue for the time being to run with this assumption, to assume that industry 1 has the higher ratio of these two elasticities, and therefore industry 1 is always the one that attracts the higher quality workers because it's better able to use them better. They contribute more to productivity, and so it's able to pay more to them, and therefore it attracts them in equilibrium. Okay, and I want to now write down the rest of the equilibrium for you. So first of all, let H1 be the number or the measure of managers that goes to industry 1 in equilibrium. Each manager is going to hire, depending upon what quality of workers they choose, a different quantity. But it turns out that you could always define here a measure of effective labor such that these homogeneous managers always hire the same amount of effective labor, where the effective labor is in fact adjusting by the quality raised to the 1 over, by the productivity raised to the 1 over gamma 1 power. That's not important. What's important is that we can have here on the left-hand side, in industry 1, the demand for labor by managers, conditional on how many of them go there. Demand for labor. What do we want on the right here? Of course, the supply of labor. So this is all the workers from the marginal worker to the top. So here's the marginal worker to the top. How many units of effective labor do we have in the economy? So in equilibrium, the amount of all the workers from QL star up have to be hired by industry 1. This is the demand for them in total. This is the supply of them in total. Same thing for industry 2. This is the number of managers in industry 2. Obviously, it's the total number of managers minus the ones that go to industry 1. This is the demand for effective units of labor, and this is the supply of effective units of labor, this time between the bottom of the distribution and the marginal workers, because those are the guys that are being hired into sector 1, into sector 2. So I have two conditions for supply equals demand. They involve the wage anchors, which anchor the wage schedules. They involve the number of managers in each sector, and they involve this cutoff. So I have two equations and 4 unknowns. Not there yet. So let's add another one. We need continuity of the wage schedule. Now if we go back to this picture, continuity of the wage schedule along here is guaranteed by condition that says that the firms are indifferent between hiring them. If there was a jump anywhere along there, the firms would want to save money and hire the guys that were cheaper because they'd only be epsilon worse and they'd be discretely cheaper. So we need continuity here, but we have that from the differential equation. We need continuity here, but we need one more condition to make sure that right here there's no jump. Otherwise, the firms would want to do something different, save on money, and hire the little bit worse quality. So that's what this condition here says, that at QL star, the wage schedule coming out of industry 1 has to piece together with the wage schedule implied in industry 2, because this marginal worker is, if you will, being hired in industry 1 and also being hired in industry 2, at least in an infinitesimal sense. Okay, so that's the third equation. And then finally, we need profits. The profits to be the same in the two sectors and also equal to 0 in a competitive equilibrium. So the salary of the managers, 0 profits in sector 1 says it has to be here. and zero profits in sector 2 says it has to be this, and equating the two, we get the fourth equation that we need, as well as the salary of the managers. Okay, so now we have 1, 2, 3, 4 equations in H1, this wage anchor, and the cutoff. And now, as they say, the rest is algebra, at least for this case. Not simple algebra, but not impossible algebra either. I'll spare you the algebra and just tell you the results. So first on the pattern of trade. A straightforward extension of the Heckscher-Ohlin theorem. So look what this says. It says, if in country A, the distribution of labor talent as a PDF is the same as that in country B, same distributions, but in country A there are relatively more managers than there are workers compared to country B. So country A is manager abundant compared to country B in this relative sense. So what's going to happen? Well, A is going to produce relatively more of the manager-intensive good. The labor-intensive good is the one with the high gamma. The manager-intensive good is the one with the high 1 minus gamma, or the low gamma. And so this says that we're going to have a trade pattern where the country with relatively many managers is going to export the manager-intensive good, just as if there wasn't any heterogeneity. This speaks to a different case now. Suppose the relative number of managers to workers in the two countries are the same, but their distributions are different in the following sense, that A, the distribution of talents of A, has the same shape as the distribution of talents in B, but it's shifted to the right. Okay, for every worker in country B, there's a corresponding worker in country A that's 1.3 times as productive, that has a QL 1.3 times as high. Okay, if that's the case, then country A is going to export the good where ability contributes more elastically to productivity. High tech in the example that I gave before. So take two countries, one has better workers than the other, look for which industry gives a more elastic response to worker quality, that's going to be the export of the country with the better workers.
This one is just like the Heckscher-Ohlin model, right? The idea.
The whole thing is a Heckscher-Ohlin model, except for the heterogeneity, yes.
No, because I was expecting when you put the distribution of productivity in the workers, then you change.
We're getting there.
Okay.
We're getting there. How does trade affect the income distribution here? Well, first thing you see, and this is also, in some sense, a negative result or an uninteresting result. If we go back to, sorry for clicking, go back to here, all the workers in industry I, the relative wage of two workers in the same industry. So if we imagine somebody with quality 10 and someone quality 5 and ask about their relative wages, well, using this equation, the WI is going to cancel out. And what we're going to be left with is some function of their relative ability, which is not going to be affected by trade. Okay, so in this setting, any two workers in the same sector, when we change the price, or when we open to trade, or when we have trade policy, there'll be no within-industry distributional effects. So, for example, if I wanted to explain the fact that I gave you at the beginning, that says that there's a lot of effect of trade on within-industry income distribution, this model is not rich enough yet to capture that. It's coming, but it's not here yet. Okay, second observation, increase the price of good 2, for example. Say that's our export good and we open to trade, so as a result of trade, the price of our export good goes up. Then the wage anchor for industry 2 is going to go up relative to the wage anchor for industry 1. In other words, the relative wage of any worker whose in the export sector is going to go up relative to any worker who stays in the import competing sector. Observation 3. Let's take the case where the factor intensities are very similar, almost equal. Okay, where the gamma 1, remember that's the coefficient on the labor, on the quantity of labor, is almost the same as gamma 2. And raise the price of good 2. Then we can say that the wage anchor for industry 2 is going to go up by more than proportion to the price increase. Put those words a little differently. That all the workers in industry 2 are going to see their real income go up. Their wage is going to go up relative to the price of good 2, even more so compared to what happens to the price of good 1, since that one's not changing. So all these guys are going to gain, and all these guys, and the wage anchor in industry 1 is going to fall, and therefore all these guys are going to lose. For those familiar with trade models, this has very much the flavor of what's called the Ricardo-Weiner model, or specific factors model. All the guys, all the different types in the export industry gain, all the different types of workers in the import competing industry lose, when, in this special case, when factor intensities are about the same. Now the other half of that very long sentence is that, let me take the case where SL is approximately 0, where that ratio of elasticities is approximately equal in the two sectors. In this case, well, we said in all cases W2 is going to go up more than W1. In this case, they're both going to go up, this is a typo, they're both going to go up relative to P2. This should say a P2 hat here. They're both going to go up relative to P2 if and only if industry 2 is the labor intensive sector. And that should remind you of the Stoper-Samuelson theorem. If the labor intensive sector is expanding, then an increase in the price of the labor intensive sector is going to benefit the factor used intensively there, which here is labor. Okay, that was a lot of words, so let me explain what's going on here. So note this model with heterogeneous labor is a blend of Stoper-Samuelson, of the Heckscher-Lean model, and a specific factors model. When we mute out the factor intensities, we get specific factors type results. When we mute out the effect of the heterogeneity, we get Heckscher-Lean or Stoper-Samuelson type results. Why? Because this is an industry where this is a model where the two industries have different factor intensities, so the Stoper-Samuelson stuff is there. But workers can't easily move from one sector to the other. In a physical sense they can, but their types make them more or less suitable for making that move. And so the next guys that come into the sector, by definition, are less suitable to move into the industry than the guys who got there before them. Because the competitive equilibrium always attracts first the guys who most efficiently should be there, and only when the sector expands on the extensive margin do we bring in the next types. The difference, this SL guy, measures how much the comparative advantage on the margin switches when we bring in the next guy versus the last guy. Okay, so if that's approximately the same, then all we're left with is the factor intensities. All we're left with is the Stoper-Samuelson theorem. On the other hand, if the factor intensities are approximately the same, all we're left with is the fact that these workers aren't all the same, and therefore we're bringing in workers who are less suitable to their new activity compared to the last. So in the extreme, where this SL is enormous, in equilibrium we'll never move anybody between sectors, and then we're in a world where the labor types are literally specific to their industry. They don't move between sectors. Okay, so already before I've introduced any matching, and as the gentleman said, so far I've introduced that, we already see that there are more complex forces than in either of the simple model with homogeneous labor, because we really have elements that are a bit like making the factor specific, and also elements like in the Hector-Lean model. I think given the time, I'm going to skip the talking about productivity and jump on. Remember, I assumed that SL was bigger in one sector than the other, or SL was positive, that this ratio is bigger in one sector than the other than for all QLs. It doesn't have to be this way. In fact, here's a very simple example of a functional form where it's not this way. Suppose there's a constant elasticity of substitution between the quality of the manager and the quality of the worker in generating the productivity of the unit. If it's the case, and if these row parameters are different in the two sectors, you're going to get a picture that looks like this. So what is this picture showing you? This picture is showing you is what the wages would have to be in Industry 1 to make the firms indifferent between hiring the different types. What the wages would have to be in Industry 2 to make the firms indifferent there between hiring the different types. And then, of course, they have to compete with each other for workers. So Industry 1 is going to get these workers, not these workers, and it's going to get these workers. So as soon as that SL changes signs, we get what we call a sorting reversal, where one sector gets the best workers, I'm pointing in the wrong place, gets the best workers and the worst workers, and the other sector gets the intermediate workers. We'll come back, we'll see this again in a few minutes. Okay, so now I want to introduce manager heterogeneity. Run you through the same exercise again. Since I'm a little bit behind, I'm going to abbreviate on this one. So we thought if we introduce manager heterogeneity, the easiest way would be to use this productivity function. By analogy to the production function, when those things are quantities, we call this the case of Cobb-Douglas productivity. Okay, so productivity now depends upon the quality of the manager with some elasticity and the quality of the worker with some elasticity. Okay, we thought this would be an easy case to work with. It is an easy case to work with, but as you'll see in a minute, it doesn't generate what we want. So we have to work with the hard case to work with. But let's go through it very quickly. Okay, here's the first order condition for the choice of worker quality. It's again the elasticity of psi with respect to worker quality divided by the elasticity with respect to worker quantity. The only reason why it looks different is now that that elasticity with respect to quality is a constant. It's this guy here. So here's that ratio of elasticities, and this is the elasticity of the wage schedule. And in equilibrium, to make these workers all get hired, we need in each sector this elasticity to be equal to the elasticity of the wage schedule, just as we had before. Now we're also choosing what quality of manager to hire. Here's the elasticity of output of productivity with respect to manager quality. Here's the elasticity of output with respect to manager quantity. Because it's constant returns to scale, it's 1 minus the 1 for labor. So that ratio has to be equal to the elasticity of the salary schedule now. Okay, so the firms are going to satisfy these first order conditions, but in fact what we know is that this has to pin down the elasticities of the two factor price schedules, otherwise some guys won't get hired. Okay, so we can write down what the wage schedule has to be. It's going to be now this form with this wage anchor and this constant elasticity, and similarly for this salary schedule. Let me skip a bullet first, I'll come back to this one. So, first of all, what you can see is that workers, when they choose which sector to work in, it's going to be once again guided by which sector has the higher alpha over gamma. The sector that has the higher alpha over gamma is going to attract the best workers, and the sector with the lower alpha over gamma is going to attract the bottom tier of workers, independent of where the managers go. So that decision can be made independent of knowing how the managers are sorted. And similarly, looking at the managers, the one with the bigger beta over 1 minus gamma is going to attract the best managers, and the one with the lower beta over 1 minus gamma is going to attract the worst managers, independent of where the workers go. So the sorting here is independent. Moreover, and it's a reflection of the same thing, within the sectors, the managers, once this condition is satisfied, different managers of different types are not going to care which worker they hire, because the relative productivity of two workers given this multiplicative separability, the relative productivity of two workers is independent of which manager they work with. In other words, by making this multiplicatively separable, we've eliminated any incentives we have to have particular matchings, because we take a manager and compare the relative productivity of two different hires he can do, and take another manager and compare the relative productivity of two different workers he could hire, and those relative productivities are exactly the same. Okay. In other words, within a sector, the matching is indeterminate. Which workers work with which managers is not pinned down here. Which workers go to which industry is pinned down. How many workers go to how many industries pinned down. Which exact pairings take place is not pinned down. Why not? Because although I've introduced complementarities between the two quality types, I haven't introduced strong enough complementarities. And therefore there's nothing to pin down exactly which workers want to get paired together or matched together with which managers. Okay, well in this case, I can prove exactly the same set of results as I showed you before, and I'll just very quickly run through them. Same distribution of worker types in two countries, same distribution of manager types in two countries. One country has relatively more managers compared to workers than the others, while the country with a lot of managers is going to export the manager-intensive good. Two countries, same relative endowments, same distribution of manager types. One country has better workers than the other. The country with the better workers is going to produce and export the good where worker quality contributes more elastically to productivity, namely the one with the higher alpha. So these are direct extensions of the case we saw before. Adding heterogeneous managers in a Cobb-Douglas way essentially leaves the model exactly the same. On the income distribution side, two workers in the same sector, we don't see any change in their relative wage as a result of trade. And we get exactly the same intersectoral effects on income distribution that I showed you before. I won't repeat them. In a word, if I want to study matching and I want to see how rematching is affected by trade, I need not only complementarity in productivity between managers and workers, but I need it stronger than is implied by this Cobb-Douglas form.
What you're going to do? Does law?
So I'm going to assume, no, I'm not going to assume a functional form, I'm going to assume that this function is log supermodular. This, as I've written it here, for those who know the term, the function is weakly log supermodular. I'm going to assume that it's strictly log supermodular. I'm going to assume, for those who aren't familiar with it, I'm going to assume stronger complementarities than are implied by the Cobb-Douglas.
Examples we get? No examples?
Let's see, yes, with the elasticity less than 0. Less than 0. Which, when I simulate the thing, is what I'm doing. So So I want stronger complementarities. I'm going to assume that psi is strictly log supermodular. I can see a few blank faces, so I'll just in a sentence explain what strictly log supermodular means. Strictly log supermodular means that if so a better worker is of course better than a worse worker. Now you ask, compare the better worker with and the worse worker when matching them with two different managers. Where is the relative advantage of the better worker bigger? Better worker is always better. Where is he more better? When he's teamed with a good manager or when he's teamed with a less good manager? Log supermodularity is the condition that says that the relative advantage of being good is more important when you're teamed with someone else who's good, as compared to when you're teamed with someone else who's bad. In terms of a more mathematical formula, as long as everything's continuous as it is here, it's just that the cross partial has to be strictly positive. Okay, so now I'm really getting worried about time, so let me show you the first order conditions. Hopefully they're familiar by now with one new twist. So in terms of terminology, first I'm going to introduce this M of QH. What's M of QH? M of QH, so M for matching. M of QH is the quality of the workers that get teamed in equilibrium together with a manager of type QH. That's something that now we're going to pin down. So this thing here now is the productivity of the manager and the workers he actually works with in equilibrium. That's psi. The notation psi IL is the partial of that with respect to L. So it's the marginal effect of worker quality on productivity in sector I, given the matches that actually occur. Here's the level of productivity. So if I also divided by the M here, which I didn't just because it made the slide look ugly, but if I divided by the M here, I have an elasticity like we saw before, which is the elasticity of output with respect to worker quality. Here we have the elasticity of output with respect to worker quantity. So the left-hand side here is that ratio that you saw before, except that it doesn't have the number of workers in the elasticity. The right-hand side would also be an elasticity if I multiply by the same thing. So the interpretation of this is the ratio of those elasticities that you saw before has to equal the elasticity of the wage schedule. So that's right, justification for why I went through. The simpler cases, we get exactly the same ratio conditions we saw before. Except that now, these ratios depend upon the matches that actually occur, which are in fact going to be determined in equilibrium. Okay, so now, we're not pinning down the wage schedule. We're only pinning down the wage schedule conditional on the matches that take place, but the matches that take place will also depend on the wage schedule. So we have evidently a much more complicated problem than we had when these decisions could be made separately. But the interpretation is the same. Two ways to expand output. Hire better workers, hire more workers. Look at how the wage schedule increases as we march up the wage distribution. Look at how much output we get from hiring better workers compared to more workers. Choose your workers accordingly. Okay. Here is the similar condition for the managers. The elasticity of productivity with respect to manager quality, which depends upon the quality of the manager, but also who he's working with, divided by the elasticity with respect to quantity. That should be set equal to the elasticity of the salary scale. Exactly the same conditions, except that Now it's more complicated by the fact that these decisions are intertwined. It's no longer possible to decide, to pin down the wage schedule knowing only things about the quality of workers, because it also matters in equilibrium which managers they're working with. Okay. It's that interaction that made us interested in this problem, but it also, as you can see, makes it mathematically more difficult.
You're going to roll out multiple equilibria here? Or,
There are no multiple. Okay, and this is a factor market clearing condition similar to the one you saw before. This is the measure of managers. This, roughly speaking, is how many workers of type M of QL, M of QH, the manager of type QH wants to hire. And over here we have how many of them there are in the relevant quality region. Given shortness of time, I'll just say that this is a condition that says that the manager's demand for workers among the types they want to hire is equal to the supply of workers that have those types. So, intuitive enough. And you can see that what we have now is 1, 2, 3 differential equations. We have 3 functions: the wage schedule, the salary schedule, and the matching function, and these guys are all intertwined. That's bad enough. But we have several other conditions. We have to make sure, we have 2 industries, remember, so we have to make sure that the wage schedule is continuous at any point where workers are switching from one sector to the other. We have to make sure that the salary schedule is continuous when we move from one sector to the other. And we have to use up all the workers at the end, so we have boundary conditions as well. I think that's what this slide says. Yes, there are 3 differential equations in those 3 things: the wage schedule, the salary schedule, and the matching function. There are boundary conditions that have to be met. We've got to check continuity. And we have to make sure that at any intersection point, the workers are going in the right direction. The ones who could earn more by being in Sector 2 are the ones that go to Sector 2, and the ones that could earn more by being in Sector 1 go to Sector 1. It sounds pretty hopeless. It was for a while. But hard work eventually pays off. Okay, so here's what we found out. First on sorting. So I'm going to give you a sufficient condition. For what we call a threshold equilibrium. So let me describe what it is first. A threshold equilibrium is an equilibrium where there's one dividing point, such that all the best managers go to one, all the managers better than that dividing point go to one sector, and all the managers worse than that dividing point go to the other sector. And there's another threshold for workers, such that all the workers better than that threshold go to one sector, all the workers worse than that threshold go to the other sector, not necessarily insisting that the best managers go to the same place as the best workers. So there's just for each factor one cut point. That's what we're calling. So I'm now going to give you a sufficient condition for the existence of that. Let's look at number one set. Since I've been talking about workers, there's symmetry, but let's look at number 2. The language will be a little bit easier. So this says, if the elasticity, so what's this? This is the elasticity of productivity with respect to worker quality divided by the elasticity of output with respect to worker quantity. If that's bigger in sector I than in sector J, evaluated where? Evaluated in sector I for the worst manager in the economy, and evaluated in sector J for the best manager in the economy. If this condition is satisfied, then the best workers want to go to sector I, and the worst workers end up in sector J. Why is that? Well, what we saw before is that these elasticities are what's pushing the workers. Well, we didn't have the matching. These elasticities, is what was pushing the good workers into sector I. A bigger elasticity of productivity with respect to quality in sector I than in sector J, compared to the similar thing with respect to quantity, was pushing the best workers into sector I. In fact, in the Cobb Douglas case, or in the homogeneous managers case, that was the end of the story. That was the story. Now there's an additional complication. Once those workers get to sector I, I'm a good worker. I say, my psi I over GABA, that's high. I want to go to sector I. I get there. What do I find? Terrible managers. I find terrible managers, and not only that, but because of the log supermodularity, those terrible managers are really bad news for me, because I'm a good worker. And I want to match with a good manager, not with a terrible manager. Now everybody wants to match with a good manager, but especially the good workers want to match with the good managers. I'm being pushed to sector I, and then I'm finding bad news when I get there. How bad can the news be? The worst manager I can have is this guy. If nonetheless I want to go to sector I, compared to the best news I could ever find going here, then despite the matching, the good workers are going to go to sector I and the bad workers are going to go to sector J. So this says, this sufficient condition says the matching that can take place can never be so bad as to overturn the forces that we saw before. Even taking the worst manager here and the best manager there. If that's the case, then it will be the case that the best workers go to I and the worst workers go to J. And quite separately from that, we can say the same thing about the managers. If it's the case that the managers, when matched with the worst workers, want to go to sector I, compared to what would happen if they got the best workers in J, then the best managers are going to go to sector I. Okay, so in this strong case, we get the sorting patterns without looking at the interactions between the two. Why are there no interactions between the two? Because I've already assumed strong enough so that those interactions can never outweigh the direct forces, if you will. So here's an example. Suppose that sufficient condition is satisfied. Well, here's an example where the best workers, so let me just show you what's on the axis. We have the quality of the managers on the vertical axis, quality of the workers on the horizontal axis. So this is showing you that the best workers are going to sector 1, together with the worst managers, up to this threshold and this threshold. And the worst workers are going to, the worst workers are going to sector 2, together with the best managers. And within each sector we're getting matching. This is the matching schedule. You see positive assorted matching within each sector. The better managers are matching with the better workers. Conditional on the sorting, but we don't have all the best workers together with all the best managers. Okay, so this is what we call an HL-LH sorting pattern. It's the best workers together with the worst managers and the worst workers together with the best managers. And this would be guaranteed to be happen if this is true for workers for sector 1 and this is true for managers for sector 2. Okay, we can say something a little stronger in the case where we're looking for a sufficient condition for now what we're going to call a high-high, low-low sorting pattern. That is to say, all the best workers and all the best managers end up in the same sector. All the worst workers and all the worst managers end up in the same sector. So notice by now these familiar ratio of elasticities. Bigger in sector 1 than in sector 2, this time for both factors. Evaluated not now at the worst and the best as we saw before, but evaluated at any constant point. Okay, so let me explain what this is going on. So this is saying, let me look here. The best managers, forgetting about where the managers are going, the best workers are being pushed towards Sector 1 because of the high ratio of elasticities in Sector 1 compared to Sector 2. But when they get there, they have to worry about which managers are going to be there. Or which managers are going to be there, if we're looking for this type of equilibrium, it's in fact going to be good managers. So that's only going to strengthen their incentive to go there. So the managers that they find there will be the better ones in the economy under these conditions. So the best workers will be happy to go to Sector 1 and to Sector 2, conditional on the managers they actually find there, provided that it's also in the interest of the best managers to go to Sector 1 rather than Sector 2, conditional on the workers that they find there. Okay, so we evaluate at a constant point. If these conditions are satisfied, all the best guys go to the same sector, and the matching only reinforces the sorting. Since everybody that's at the top of the distribution is going to the same sector, the ones you actually find there will only enhance your productivity, make you even happier, as it were, that you decided to go there in the first place. And that gives us an equilibrium that looks like this. Now we have all the worst workers, managers and all the worst workers in Sector 1, and the best managers and the best workers in worst in Sector 2, best in Sector 1, positive assortative matching in each industry, and now in fact positive assortative matching throughout the economy. Now, the truth of the matter is that before I showed you the sorting reversals that we saw before, we couldn't get the DAM model to solve for the CES case that we were doing. We couldn't get it to solve because we were looking either for this or for this, and we weren't finding any equations that were solving those differential equations. Okay, but now we know, in fact, that even when the managers were homogeneous, we could get these sorting reversals for the CES case. We were using a CES case. We should have been looking for sorting reversals. In fact, we can have them here as well. So what does this picture show you? This picture shows you that the worst workers down here at the bottom of the distribution and the best workers up here at the top are going to Sector 1. Who are they finding there? They're finding their managers above here. They're finding good managers. So these are positive assortative matching of workers and managers down here, positive assortative matching here. In fact, positive sorting matching throughout the sector, but this discontinuity in the workers that actually go to the sector, just as we saw even when the managers were homogeneous. And down here, we have a middle tier of workers matching together with the lower tier of managers. So once we realized that this kind of sorting reversal could take place, we hired a graduate student who was better at MATLAB than we were, who could program and look for such things. Lo and behold, the computer immediately found this equilibrium. Skip the pattern of trade because what I want to tell you about finally is how trade affects the income distribution in this more subtle case. And this is where things get more interesting. Okay, so let's look at one of these high-low, low-high equilibria, such as the one I showed you here. Okay, so I'm going to start off, there's no trade. All the best managers and worst workers go to Sector 2, and all the best workers and worst managers go to Sector 1. So I repeat that here. All CD is best managers and the worst workers. AB is the best workers and worst managers.
The evidence suggests that we are in the other world, where you have sectors with high wages for all kind of workers, managers, and no.
I'm not sure we know that, but I have that case as well. now I'm going to raise the price of good 2. I'm going to raise the price of good 2. What's going to happen? Well, the first thing that's going to happen is that's going to draw resources into sector 2. And that's standard and classical, you wouldn't expect otherwise. More managers are going to want to work in sector 2 with a higher price. More workers are going to want to work in sector 2 with a higher price. So what does it mean that more managers are going to work in sector 2? Well, it means originally these guys were in sector 2. Now more of them are in, namely these guys. And originally these guys were in sector 2 among the workers. Now more of them are going to move in, namely these guys. So now we have to match together this set of workers with this set of managers, when formerly we had this set of managers with this set of workers. I won't point to it because I'm confusing myself. But what you can see, as we, on the margin, we're bringing into sector 2 some better workers than we had before at the margin, and also expanding the managers at the bottom end. What's going to have to happen to matching, and we prove this rigorously, but it just shows on the figure here, is that every worker is going to have to get a worse manager than he had before in sector 2. We brought in more managers, but on the margin, we deteriorated the management pool. And we brought in more workers, but on the margin, we've improved the worker pool. So with better workers and worse managers than we had before, how can we make that all work out? We got to match workers with worse managers than they had previously. Okay, so every worker of any given type, after the opening of trade, is now going to end up with a worse manager. He's not going to want to leave, because this is an equilibrium. He's going where he's getting paid the most. But compared to what he had before, he's going to end up with a worse manager. He's going to have a higher price for the sector, therefore a higher marginal product. Therefore, he's happy to be there, but he has a worse manager. And similarly, for the workers who remain in sector 1, every one of them is going to end up with a worse manager. Okay, so in this economy, except for the few guys here who are switching sectors, all the workers are ending up with worse managers. So what does that mean for within industry income distribution? Okay. Well, having a worse manager here is bad news for everybody. But who's it especially bad news for? Well, because of the log supermodularity, having a worse manager is particularly bad news if you're one of these guys compared to one of these guys. Because these are the guys who most benefit from having a good manager compared to these guys. So these guys up here are going to see their relative wage decline compared to these guys. In other words, the better paid workers are going to see their relative wage decline compared to the worse workers. In other words, in that industry, the income distribution is going to improve. Bigger relative gains for the guys at the bottom. Here too, everyone's manager is deteriorating. Who's that hurting? Well, especially these guys up here compared to these guys here. So in this industry as well, the relative wage of these workers is going to decline relative to these workers. So in fact, throughout the economy, the relative wage of better workers declines relative to less workers in each sector. The overall wage inequality improves. Now that sounds like a happy story. Of course, there's the other possibility. You could be exporting the other good. The other price could have gone in and we get exactly the negative side. But the point is that we can say throughout the distribution here that what's going to happen to the rematching, and through that what's going to happen to the income distribution. So here's the overall, I'm sorry?
This is because there are no migrations across countries. It's just within.
Just within countries. You can see in the U.S. how excited people are about allowing migration across country. So this is just putting some functional forms on it and shows you, first of all, remember we're raising the price of good 2. That's going to raise the wages of good 2 of sector 2 relative to wages in sector 1. Why? Because of the Ricardo-Wiener specific factors considerations we saw before. So these guys in red are going to do better compared to these guys in blue. Within industry, you can see that the biggest wage increases go to the guys at the bottom. That's the improvement in the wage distribution. In fact, for the numbers underlying this, this is a 5%. It should say that someplace. 5% increase in the price. So these guys are actually getting a real wage increase. These guys over here are getting a real wage decrease. Why? Because this is the labor-intensive sector. This is the manager-intensive sector. So that's the Stoper-Samuelson forces. Within each sector, we're getting bigger gains, or in this case, smaller losses for the guys at the bottom of the wage distribution compared to the guys that are higher up. So, general punchline, and general punchlines have less specificity in general. But the general punchline is there are 3 forces that always determine the effects of trade on the income distribution. There's the factor intensities that we're familiar with from Stoper-Samuelson. There's the specificities that come from the fact that certain types of workers have comparative advantage in one sector than the other. If you have a comparative advantage in the education sector, you want to see the, and how do you have that? By having high ability, because that's particularly good in the education sector. Then you want to see the price of the education sector going up relative to going down. That's 2. And then there's the rematching that takes place. And that depends in a subtle way on the sorting pattern, whether it's HL or LH or HH. But in this case, we know that clearly the workers are going to end up with worse managers than before, and therefore that's going to benefit the guys at the bottom. So you tell me the particulars of a case you have in mind in terms of these technologies, and I can, if it's not too complicated, work out how the income distribution is going to change. This one is a case where, in fact, the income distribution gets worse in each sector. But there's a question.
Yes. Go to the looking at your first example, when the best workers team up with the worst manager and vice versa. They, the idea of your story, there is the salary inequality is decreasing when the price of the sector 2 is increasing, and so on and so forth. You have explained it. Now my question is about the productivity of sector 2, because the salary inequalities in both sectors, they are decreasing. But what about the productivity in each sector? Does it change or not?
Yeah, that's remember I slipped over that slide, but since you asked the question, I'll certainly answer it. Depends on what you mean by how you measure productivity. So this is a model in which there's no imperfect information, there's no market imperfections, everything is efficient, technologies aren't changing. So if we correctly accounted for everyone's ability, then by definition trade has no effect on productivity. In fact, when we actually measure productivity in economies, we don't usually have that detailed information about every type of worker. So we usually take aggregates and we do something like total factor productivity or something like that, without making these fine adjustments for worker quality. If we don't, then this model says what will happen to measured productivity. In particular, I showed you an example where trade draws in, trade sheds from sector 1 these workers, These workers were the worst workers in Sector 1. They're leaving. So productivity in Sector 1, as we measure it, if we don't take that into account, is going to go up.
Exactly.
Who's going to go in Sector 2? Well, it's going to be these same workers are joining. They're better than the ones that were there before. So productivity is going to go up in Sector 2. So in fact, productivity will go up in both sectors in this case. In the country that exports good 1, it'll be exactly the opposite.
Yeah, but the managers is also, there is the worst manager goes to the sector 2, while
Right, so in the case where it's HHLL, then on both margins you get an improvement in productivity. But what you're saying is right. In this case here, against that will be the fact that the opposite managers are coming in, and then it's an empirical matter, or it's a measurement matter. There's no clear analytical result. Okay, I've run out of time. Let me just think how I want to summarize. So what I've given you is a framework which incorporates the features that we know from trade, factor intensities and factor comparative advantage, together in this last instance with a determination of the pattern of matching. The pattern of matching can be pretty subtle, in particular difficult because it interacts with the pattern of sorting, so that positive sorted matching says that the good workers want to be together with the good managers. That can run a counter to the fact that there might be forces pushing the good workers to one sector and the good managers to the other sector. And so, in reality, as we try to explain this set of facts that I showed you at the beginning, we're going to have to put in quite a lot of specificity about the nature of the technologies we're working with, because we're not going to have general results. I'm losing my voice, let me